All right, so we're taking a look at this one. So what we've got here is we're looking for the slope of the tangent. So your first step, ladies and gentlemen, is what you're determining is f prime at 3. Notice your x value is 3. So that's what we're after. We're after f prime of 3, which means that we're looking for the limit as h approaches 0 of f of 3 plus h minus f of 3 over top of h. And if that's not your first step in all of the homework that you've done, go back and redo your homework. Okay? That should be our first step. That's what this is. This is the slope of the tangent to f of x when x equals 3. That's exactly what this is. So what we're going to do is we're going to do the limit as h approaches 0 of f of 3 plus h. So everywhere there's a 3 plus h, we're going to plug it in everywhere that there's an x here. So it's the radical of 3 plus h minus 2. And then it's going to be subtract the radical of 3 minus 2, because now it's a 3 that I'm plugging in, over top of h. Notice if I allow h to approach 0, well, I can simplify this up a little bit. We can make this look nicer, first of all. I've got 3 minus 2, which last time I checked is 1. And I've got 1 over here. So if h approaches 0, this will be root 1, which is 1. Subtract root 1, which is 1. So I'm going to get 0 on top over 0. That's indeterminate form. We know that we have more work to do. So whatever are we going to do? Well, the first thing I'm going to do is make this look easier, because I don't know about you, but root 1, I'd much prefer talk about it as 1. How about you? Then I'm going to multiply by the conjugate. Top times top, bottom times bottom. But being smart, this is a difference of squares. So it's going to be the first term squared. So it's going to be h plus 1. Subtract 1 squared, which is 1. Over top of, and do not expand the bottom. That would be absolutely ludicrous. Expanding the bottom is not a good thing. We want to be able to reduce out a 0 term. We want the bottom to stay factored. For reducing purposes. So on top, what do we have? We've got the limit as h approaches 0 of h over h root x plus 1. Is it x? How did I get an x? There shouldn't be any x's. Where did I get an x? That should be an h. That should be an h. That should be an h. Plus 1. These h's are going to reduce. And this is going to be the limit as h approaches 0 of 1 over root h plus 1 plus 1. Turn on the limit. Ring-di-di-di-ding, ring-di-di-di-ding. That goes to 0. So it becomes 1 over 1 plus 1, which is 1/2. The slope of the tangent line to that radical up there is going to be 1/2. And if you wanted, just so that you're understanding what's going on, remember what the curve was. It was f of x equals x minus 2. From grade 11, you should remember that that is this curve. Do we all agree? I'm looking to my studio audience. That should be that curve. So when I'm looking at x equals 3, what we've determined is the slope of the tangent line at that point. The slope of the tangent line at x equals 3 is equal to 1/2. So in other words, rise over run. I'm going to go over 2, and I'm going to go up 1 there. That's what this means, people. That is the slope of the tangent line. We're going to go over 2 and up 1 for this tangent line at x equals 3 for this curve. I'm going to pause the video there, and we'll be right back.